The first part of chapter 4, we're going to talk about angles and different things about angles. So things that we need to understand is what an angle is. Okay, we're not going to geometry. Don't worry about that. But we are talking about what an angle is. An angle has a starting side and an ending side. Your starting side is the initial side. It's where the angle starts. So that would be your initial side. And then where the angle ends is your terminal side. And why that makes a difference, you'll see in a second here. But an angle always has an initial side. It's the starting position of your angle. And then the terminal side is where it ends. Okay? We're going to talk about different kinds of angles. We're going to talk about positive angles, and we're going to talk about negative angles. So in anything that we're talking about with trig stuff, you're always going to have an angle that starts in standard position. What does that mean? Standard position means the initial side, where the angle starts, is the positive part of the x-axis. We always start from there. This is 0, right? Everybody understand that? And then your angle rotates, and then you'll have a terminal side. You'll have where it ends. There's going to be two different kinds of rotations. You can have positive angles and you can have negative angles. So from our terminal side here, if you have a positive angle, 90 degrees, 170 degrees, you start from the initial side and you go upwards like this. Right? This is a positive angle. When you have angle measurements, a positive angle, you start at the x-axis and go up. If you have a negative angle measure, which way do you think you go? The opposite. You start at the x-axis and you go down. This would be your negative angle. Meaning you have an angle measure of like 94 degrees. That means you start at the x-axis and you go 94 degrees. This would be like negative 135 degrees. You start at the x-axis and go down. You end up in different quadrants. You're going to need to know the quadrants and all that stuff. All right, I just talked about that, positive and negative angles. We use the terms clockwise and counterclockwise, but sometimes that can be confusing, so I always say up and down. A positive angle starts here at the x-axis and goes up. A negative angle starts at the x-axis and goes down, the way you measure it. Everybody see that? Okay. Then we have stuff called coterminal angles. All right, coterminal angles. What does that mean? Well, a coterminal angle can be one angle written two different ways. So do you see this angle right here? Do you see this angle here? You could say that if you went in the positive direction, you went up this degree measurement. But if you went in the negative, you went this degree measurement. But you end up in the same spot. Same thing over here. I have one angle as if I went from the initial side and went this many degrees, or I went from this side and I went this many degrees the opposite direction. I ended up in the same spot. Those are called coterminal angles. You guys aren't going to have to draw these. You're going to have to figure out what the measurement would be. Coterminal means we add and subtract a whole circle. So think about it. If I have this angle is 30 degrees, right? And then I go one whole circle around. How many degrees are in a whole circle? 360. So the angle measure of 30 degrees and the angle measure of 390 degrees are the exact same angle. I could add another whole circle to that, to 390, and get another coterminal angle. I could subtract, if I said 30 minus 360, I'd get a negative angle measurement. But if you were to plot it on a graph, you get the same spot. So when we talk about coterminal angles, you're adding and subtracting 360 degrees, a whole circle. It's always the angle plus or minus 360, not 360 plus or minus the angle. The angle always has to come first when you're computing. It's real easy. If I asked you guys, if I gave you an angle measure of 17, I said 17 degrees, I told you to tell me two coterminal angles, one positive, one negative. You'd add 360 and subtract 360. Some of you could add 365 times and get a coterminal angle. It doesn't matter. All you're doing is just saying you come back to the same spot because you had a whole circle. And we'll talk about that in radians as well. Hang on. All right, the central angle. The central angle. Where is the center of a circle? In the middle, right? Your central angle, we're always going to be talking about central angles, is right there at the origin. We're always going to be talking about that. All right, so when we talk about a whole circle, we said there's 360 degrees, correct? Yes? How many of you talked at all in Algebra 2 about radians? Anybody? A little bit? Okay. We're going to talk about radians, and a lot of trig stuff is in radians. It's another way to measure circles. An entire circle is cut up into 6 radians. A radian is about 59.5 degrees, whatever. But you guys do not have to, you don't have to memorize the unit circle. Some of you have had to do that before, but you guys don't have to. A radian measure is the relationship between the arc length on the outside and your central angle theta. But what I need you guys to understand is that all the angles that we are measuring from are always going to be centered here at the origin, and that's going to make a big difference. You're going to see why in a second. We're going to see why in this whole chapter. But it's important to understand that any angle that we talk about is always going to be centered at the origin. So you know if you go left and right, that's your x-axis, up and down is your y, that sort of a thing. Our terminal side is always right here on the x-axis. Right. A radian, like I just said, is the measure, or it's a relationship between the arc length on the outside and the central angle itself. We're not going to be finding that right now, but just understand that that's how the conversion comes. So let's talk about our quadrants. Do we remember our quadrants from geometry? Quadrant 1, right over here. Quadrant 1 is over here. And then we go in the shape of a C, right? You go to the left. This is quadrant 2. This is quadrant 3. And this is quadrant 4. This is going to be really, really important for you guys to know. Let's talk about signs. What are the X and Y? What's the sign of X and Y in the first quadrant? They're both what? Positive, positive. If I told you to go from the origin, tell me something in the first quadrant, you would go right and up. Those are both positive. So in the second quadrant, what are the signs? If I go left, it's what? Left is negative, and then up would be positive. In our third quadrant, left and down. Negative, negative, good. And on our fourth quadrant, right and down. Positive, negative. It's going to be super important for you guys to understand. Now, when I look at these quadrants, this is 0 degrees, right? Or 360. This is 90. This is 180. And this is 270. You guys agree? We also need to know our radian measure. One whole circle, 360 degrees, equals 2 pi. So half of that is pi. That's our 180. If you cut them into quarters, it'd be pi over 2 is 90 degrees, and 3 pi over 2 is 70 degrees. And we'll talk about conversions and stuff here in a little bit. But you guys need to understand that 90 degrees is the same as pi over 2. 180 degrees is the same as pi. 270 degrees, same as 3 pi over 2. And 0 and 360 degrees is the same as 2 pi. It's one whole circle. All right, so if we're going to find coterminals, and I'm going to look at your website and see. I may not have you guys type this in like in website. When they have this right here behind it, that just means n is any number. 2 pi is one whole circle. So if I say I want to find a coterminal angle, right? I start off with 30 degrees, then I add a whole circle, and I'm at 390, then I add another whole circle. N is the number of times you can spin around your unit circle or your quadrants or whatever. So when you are asked, guys, to find a coterminal angle, all right? Write this down, coterminal. This is the only thing I need you to know from this, is how to find it, and then we'll talk more about what to do with it later. But coterminal, you're going to add and subtract 360 degrees from the angle. But say they give you the radian measure. They don't give you degrees. You're going to have to add and subtract. What's one whole circle? 2 pi. All right, so when we see coterminal, you add and subtract a whole circle. If it's in degrees, you stay in degrees. If it's in radians, you stay in radians. Don't worry about this. All that's saying is I can go 2 circles around. I can go 5 circles around. That's all that's saying. You don't have to worry about that. So if you have a question and it gives you this, it tells you theta, the central angle that we're talking about is 13 pi over 6. Okay, here's my angle, 13 pi over 6. I want two coterminal angles. They're going to ask you for one that's positive and one that's negative. So we're going to add a whole circle to that, and then we're going to subtract a whole circle. So if you're adding and subtracting fractions, what do you need? A common what? Denominator. What's a common denominator between 6 and 1? 6. So if I multiply the bottom here by 6, I have to multiply the top by 6, right? What's 2 times 6? 12. So when I add 13 pi and 12 pi, I get what? 25 pi over 6. Is that a positive number? Yes, so there's your positive coterminal angle. So now I need to find a negative one. So again, if we're going to add or subtract fractions, what do I need? A common what? Denominator. What's my common denominator between 6 and 1? 6. So I multiply the bottom by 6, and I multiply the top by 6. What's 13 minus 12? I get 1 pi over 6. Is that a negative number? No. Did you guys find one positive and one negative coterminal? No. What'd you find? 2 positives. Either one of these would be a correct answer for a positive coterminal angle. If you guys put the top one in WebAssign or the bottom one in WebAssign, you put the top one as a test question or the bottom one, it's fine. But what would I do you think, to find a negative coterminal? I got to subtract again. Perfect. You just keep adding until you get a positive number. You keep subtracting until you get a negative one. So I'm going to subtract, again, 2 pi. Which, again, what's my common denominator between 1 and 6? 6. This becomes 12. So what's pi minus 12? Negative 11 pi over 6. There's your negative coterminal. Either one of these could be an answer as the positive. It's very easy. All you're doing is saying, okay, here's this angle measure, right? Here's this angle that I'm talking about right here. So if I start here and I add a whole nother circle, I get there again. If I add 2 circles, I get the same spot. 3 circles, you just keep adding and subtracting one whole circle. You end up at the same spot. That's all coterminal means. All right, here's my theta. They gave me 3 pi over 4. I want to find one positive and one negative. You always start with the angle first. Since we're in radians, you keep it in radians. What's one whole circle? So I'm going to add 2 pi, and then I'm going to take 3 pi over 4 and do what? Subtract 2 pi. That's it. Very, very simple. Mechanically, it's very simple. What's a common denominator between 1 and 4? Guys, common denominator between 1 and 4. 4. So I multiply the bottom by 4, then I multiply the top. So what is 3 plus 8? 11 pi over 4. Is that a positive coterminal? Yeah. Could I add 2 pi again and get another positive coterminal? Yeah. Just keep adding a circle. It's fine. So now when we subtract, common denominator between 4 and 1, 4. So this becomes 8. So what's 3 minus 8? Negative 5 pi over 4. Is that a negative coterminal? Yes. There you go. There's your answers. So it's even easier, guys, if it's in degree measures, because if it's 200 degrees, how do you find a positive? You add 360. How do you find a negative? You subtract. The thing is, though, the angle always has to come first. Don't do 360 minus 200. Do 200 minus 360. Angle always first. All right. How's this one a little different? What are we starting off with? We're starting off with a negative. Do the rules change? No. If I want to find from this negative, what does that negative mean? It means I started at the x-axis, and instead of going up, I went which direction? Down. That's it. So I'm still going to add 2 pi And I'm going to subtract 2 pi. We keep adding till we get a positive. You keep subtracting till you get a negative. So common denominator, guys, between 3 and 1. 3, so if I multiply the bottom by 3, then I multiply the top. 3 times 2 is 6. So what's negative 2 plus 6? 4 pi over 3. Is that positive? Okay, we're good. Now let's find the negative one. Now I'm going to subtract a whole circle. What's your common denominator again between 3 and 1? 3, so multiply the bottom by 3, then the top. So negative 2 minus 6 is, so negative 8 pi over 3. 1 positive, 1 negative. Pretty simple? Okay. Coterminals are easy. So when we talk about degrees, that's what our brain has been focused on. That's what you guys have learned your whole life, is everything is in degrees. All right, we go, the first quadrant is 0 to 90, then 90 to 180, then 180 to 270, then 270 to 360. So now we're going to have to start thinking in terms of pi. We're going to have to start thinking in terms of 1 whole circle is 2 pi. Half a circle is pi, that sort of a thing. You guys also should know our special right triangles. We're going to talk about those, but our 30, 60, 90s, and our 45, 45, 90. That's going to come back to us. We're going to talk about right triangle trig in section 4.3, but those special right triangles are going to come back to us. We'll talk about that later. All right. How do we get from one thing to another? Degrees to radians and radians to degrees. All right. Again, if you guys see this, 360 is the same as 1 whole circle. 360 degrees, 2 pi radians. So if I cut 360 in half, I get what number? 180. So if I cut 180 in half, I get half a circle. If I take 2 pi, which is a whole circle, and cut it in half, what do I get? Pi. That's the same as half of a circle. Does that make sense? If I cut this in half, what's 180 in half? 90. If I take pi and I cut it in half, it's pi over 2. Okay? That's how that comes about, the conversions. So let's talk about conversions. All right, you guys are going to have to do conversions. This is super easy. You don't have to worry about like, oh my gosh, there's so much to memorize and all this stuff. No, you don't. Your conversion factor is either pi over 180 or 180 over pi. Because think about it, we're going to be going from degrees to radians or radians to degrees. What is the relationship between pi and 180? It's the same thing. They're equal. Good. So how are we going to go about changing from one to the other? We're going to convert. It's super easy. Let me show you how to do it. This is just a good visualization of 30 degrees is pi over 6, 45 is pi over 4, 60. This is a good thing to know or to just be familiar with. Okay, this is how we do our conversions. Obviously, it's going to say convert. What are we starting in, degrees or radians? We're starting in degrees. All right, this is a whole number, so it's over 1. So I'm going to take my 135 degrees over 1, and I'm going to multiply it. What do I multiply it by? 180 over pi or pi over 180? What do we want to cancel out? The degrees. So if you want something to cancel out when you're multiplying fractions, 1 has to be in the numerator and 1 has to be where? In the denominator. So it should make sense that if I'm starting out in degrees, then I want degrees on the bottom, because what's going to happen? The degrees will do what? They'll cancel. That's a good way to remember that. And then you guys could do whatever you want here. You could say 135 times pi divided by 180, or you can go ahead and cross cancel. What number goes into both 135 and 180? 5, okay. 5 goes into 135 how many times? 135 divided by 5. Goes into, right, this is 27, agreed. And then 5 goes into 180 how many times? It's 180 divided by 5, guys. 3, 15, 36. Can I simplify that more? What goes into 36 and 27? Okay. 9 goes into 27 3 times. 9 goes into 36 4 times. So what am I left with in my numerator? 3 pi over what? There you go. You just converted from degrees to radians. What do you guys notice about 540? Bigger than what? It's bigger than 180, but it's also bigger than one whole circle, right? 360, okay? But think about it. What are we starting off in? Are we starting off in degrees or are we starting off in radians? We're starting off in degrees. So what do I want to cancel out? The degrees. So where do I put my degrees so it cancels out? On the bottom. There you go. That's all you got to think about. What do you want to cancel out? So right away, I see that my 0 and my degrees will cancel because you can divide both by 10, right? And then what number goes into both 54 and 18? Let's do 2. This is 27, and this is 9. Yes? Okay, what number goes in there? 9. 9 goes in here once. 9 goes in here how many times? So what am I left with? There you go. That's your conversion. How do you find coterminal angles? What do you add and subtract? 360 or? Okay. Now we're converting. You convert 180 over pi or pi over 180. You guys want to do one that starts off in? I mean, it's pretty simple when you do this. Okay, how about I'm starting off with negative 7 pi over 4. What does that negative in front of the angle mean? If I was going to draw it, what direction do I go? Down. When you're converting, the only thing that you do is keep the negative with it. Right? This is a negative angle. It's going to be a negative angle when you convert it to degrees. So think about it. I have negative 7 pi over 4, and I want to convert it to what? I'm obviously starting out in radians because I don't have a degree symbol, and I have a pi in it. So where does my 180 go, and where does my pi go? 180 goes on the top, and pi goes where? On the bottom. Perfect. So right away you can see, oh, pi on top cancels with pi on the bottom. That's what we wanted. Does 4 go into 180? How many times? 45. So now what do? I multiply. 7 and 45 is what? 45 times 7. 35, 28, 29, 30, 31, 315. So it's negative 315 degrees. So what does that look like? Let's just talk about this for a second. This is negative 90, negative 180, negative 270, and this would be negative 360. So negative 315 is in which quadrant? I'd start here, and I'd go around. What quadrant does it end up in? The first quadrant. It's right here. Negative 315 is the same as what? How would I find a coterminal angle? Add 360 to that. Negative 315 is the same as what? Positive 45. They're in the same spot. You see how they're coterminal, they're in the same spot. They're both in quadrant 1. Just the direction that you would go to get there is how that changes. All right, going back to geometry for just a minute. Complementary is the sum of two angles. That's 90 degrees. Complementary means when I add the two angles together, I get 90 degrees. But what is 90 degrees the same as in radians? Pi over 2. If you are asked for the supplementary, it's when you add the two angles together, you get what? 180 or pi. All right, so we're going to talk about 3 mechanical things today. We're going to talk about finding coterminals, adding and subtracting 360 or 2 pi. Finding degrees to radians, radians to degrees, just converting pi over 180, 180 over pi. And then here, we need to know complementary is 90, supplementary is 180. So if you are asked here, last thing we're going to talk about, to find the complement and the supplement. When it's in degrees, super easy. All right, if I'm going to find the complement means it adds up to be what? 90. So you take 90, you subtract 72, and you get what? How much? 18. So 18 degrees is the complement. To find the supplement, you take what number? Supplement means what? 180. So 180 minus your angle is 72, and you get what? 108, okay. Easy enough, right? You guys agree? Okay, let's do the next one. Find the complement of B. Complement, you take 90 and you subtract 148. Well, what do you notice about this? If I say 90 minus 148, what kind of a number am I going to get? A negative. So what's my answer to this one? There's no complement. In order to get a complementary or supplementary, the two angles have to add to 90 or add to 180. If it's bigger than 90, then there is no complement. But you always have to have the angle second in this case. It's 90 minus and 180 minus, not the other way around. Just got to be careful with that. So this one is supplement. When I see supplement, what number do I think? 180. So 180 minus 148 is what? What is it? Okay, 32 degrees. There's your supplement.
So if it's bigger than 90, there's automatically no.
Correct. If it's bigger than 90, there's automatically no complement. If it's bigger than 180, is there a supplement? No. So how do things change a little bit if you are talking about radians? Well, there's two things you can do. First thing you could do, could you convert? Can you guys convert this to degrees and then do 90 minus? Sure. It's going to take a little bit of time, but if you want to do that, you can. I'm going to do it in terms of radians. So if I have C to find the complement, it's 90 minus. What's in radians, what's 90 the same as? Pi over 2. So it's pi over 2 minus 2 pi over 5. Again, if you wanted to convert it to degrees and do it that way, you could, but then you have to convert your answer back to radians. Whatever measurement you start with, you have to finish with. So what is my common denominator here, guys, between 2 and 5? 10. So if I multiply the bottom here by 5, I get 10. So I multiply the top. You guys agree? Over here, I multiply by 2. And then I multiply the top by 2, and I get 4. So what's 5 minus 4? 1. So it's pi over 10. Is that a positive number? Yes. So that's your complement. If I'm going to find the supplement of this angle, it's 180 minus. Well, what is 180 in terms of radians? So it's pi over 1 minus 2 pi over 5. What's your common denominator here? 1 or 5? 5. So if you multiply the bottom by 5, then you multiply the top. What's 5 minus 2? So the supplement of this would be 3 pi over 5. Again, if you converted that to degrees, then did 90 minus, 180 minus, you're more than welcome to. But the only thing is then you have to convert your answer back to radians. So let's do D real quick and then we're done. Do you see why we're not doing everything today? We still have like 3 more slides. All right, so complement. What's the complement in terms of radians? Pi over 2. Okay, so pi over 2 minus 4 pi over 5. Common denominator between those two. 10. All right, so if I multiply the bottom by 5, I get 10. So I multiply the top by 5. Multiply the bottom by 2, I get 10. So multiply the top. What's 5 minus 8? Negative 3 pi over 10. If you leave your answer like that, I'm going to mark it wrong. What is your answer to what is the complement? You would say none. As soon as you get a negative number, there's no complement. If you get a negative number with the supplement, then it's none. Don't leave it as a negative. So same thing here. What is your supplement? It's 180, right? What's 180 in terms of radians? So pi over 1 minus 4 pi over 5. Common denominator. 5. Multiply bottom by 5 at the top. So 5 minus 4 is 1 pi. So 1 pi over 5. That's your supplement. For your WebAssign for this, I'm going to move the date out, but for your 4.1 WebAssign, don't worry about putting it into WebAssign. If you want to check your answers, that's fine. But for the coterminals, I think you have to add the 2 n, k, or whatever. Don't worry about doing that. It's pretty much just a lot of conversion. You can't do it all because I didn't finish the lesson yet, but I'm going to move the due date to Friday at the end of class, so you guys have plenty of time to work on the 4.1. Okay, we're good?